That looks better. All right, so today is a programming lecture today. This will be the last lecture on Scratch. That's exciting. We're ready to move on after this one. So without any further ado, let us get started. Program creation and just finishing up all the things that I wanted to talk about with Scratch. So yeah, here are a few fancy examples, I think. So I want to just talk about, in general, you're going to have a problem thrust upon you by like your boss or somebody one day, your professor, and you need to eventually figure out how to solve that problem, right? What are the steps required? How am I going to make this program do all the things that it's required to do? Because one day you're not going to get every single requirement listed out for you, like I've been nice to do in this class, right? So let's learn how to just create programs. What's a good step-by-step method to make a program and hopefully make it be correct, okay? So to write a correct program, to do something, perform some task, you have to know really these three things. They're probably the most important three things about the problem. So you need to understand the problem itself, like what is being asked of you? What are you required to do mathematics? Are you required to do some sort of simulation? Are you just, I don't know, drawing something to the screen? Like what is the problem itself? What are the concepts involved? Do I need to go study up on statistics or something in order to make this all work out? Or do I have the tools in my mind already? So concepts involved, etc. Understand the problem, what's being asked of you to do before you make a program that solves that problem, right? Solve it on paper first, know how to do it. And then you need to understand very, very thoroughly the inputs and the outputs to the program that you're going to write. All right? So the inputs are what you are getting from the user. Like, what are they typing to you? Are they giving you an entire spreadsheet? Are you doing something with that? Or are they just giving you, like, a single number? So what will the user give you? Are they going to type their name? What am I going to do with that? What will the user give you? Because that's all you have to work with, right? You better get everything you need. What will the user give you? That's what it means to be an input. And then the output is what your program does with the inputs. It's just essentially a big arrow from input to output. What you take stuff in and you jumble it up and then you spit something out. What is the result? Maybe multiple results. What's the answer that your program gives back? Maybe it's generating a giant spreadsheet. I don't know. Or maybe it's just averaging stuff and it gives back a single number. So what is the answer you're trying to compute? For some definition of answer, I'll put that in quotes. Because maybe you're making like a video game or something, and that's your output. Animations on a screen. What is the answer that your program gives back? Okay, so that is the goal. Once you understand those three things, it's not too hard, in theory, to write a program that does it, assuming you're ready to do it. You have the skills. So yeah, essentially you're just making your program. All it is it's some method, some algorithm, some strategy that takes your inputs and maps them to the outputs that should be associated with them. Like, I don't know, if you make a program that adds two numbers, like you should be able to take 2 and 3 and output 5. Right? So inputs to outputs. That is all a program is. That is all an algorithm is. It's just a recipe to make something that you want to make. Okay, so that's essentially the process. That's what you go through every time you write a program. Any questions about that? That's what I want to just spell out for you so that you can do that kind of process yourself. All right. So yeah, let me show you some ways, some different processing styles. Let us do a mathematical program first in Scratch. Let's make a program that calculates the factorial of a number n. So it calculates n factorial, where n is some input that we get from the user. So say the user types 5, that'll set n to be 5, and we need to give back 5 factorial, which is 5 times 3, or 5 times 4, right? 5 times 4 times 3 times 2 times 1. That's the factorial, and apparently that answer is 120. I did it ahead of time. Okay? So if this is our problem, calculate n factorial, where n is a user input, then, okay, what's our input, what's our output? The input's a number. It's what do we want to take the factorial of? Like, we're getting that from the user, storing it into a variable. There it is. And then the output is also a number, right? It's the factorial of that input. If the user gives you 5, you calculate 5 factorial and you spit out 120, okay? That is the input and output relationship, and that's important to understand. And the problem itself is, all right, we take some number and we find the factorial of it, and we have to break that down into little bite-sized pieces. Hopefully, they get to be small enough that we don't choke on them and it's not too hard, okay? So you can think about this in terms of like a main problem to solve. Like you get a number and you're computing the factorial of it. It's like, all right, I need to start my n at 5 and like I need to like compute some answer involving n. Maybe I'll have it count down 4, 3, 2, 1 and I'll multiply all those into a number or something. That's one problem. And then there's also other problems that you can think about. Like what if the user is asking me for a factorial of something that doesn't exist? Like the user tries to ask me for the factorial of a like -5 instead of +5. That doesn't exist. That's not defined. So maybe we should yell at the user. That's another problem to solve once we've solved the main one. That's like a sub-problem. Yeah, so we'll have to think about that too. But yeah, once you have all the inputs and outputs in mind, it's not too hard to break things down like this. And here is the process. Here's how I'll solve the factorial computation problem. We're going to take two variables. The number we got from the user, we'll have that to begin with. Then I'll also make another variable called out. And the idea is I'm going to multiply a bunch of numbers into out. And so out will start at 1, not 0, because if I multiply a bunch of numbers into 0, it'll stay 0. I want it to start at 1, and then I can affect it by multiplying into it, all right? And the idea is I'm going to multiply 5 into out, so out is out times n, so now it's 5. And then I'll make n smaller. I'll make n 4 now, because that's the next number in the factorial that I want to multiply into, right? And then I'll multiply 4 into out, and that'll make it 20, right? And then eventually, I'll just keep doing that. Keep multiplying n into out and decrementing n. So now it's 3, multiply the 3 into out, that'll get 60 into there, then decrement n to give me the next number that I want to compute the factorial on, right? 2, multiply that into out, I get 120, and then it's 1. Technically, I could stop here if I wanted to, but why not? Let's keep going. Multiply the 1 into out, it stays 120, and then decrement n one more time, it's 0. I do not want to multiply 0 into out, right? That will make the whole answer 0, so I better stop before I get there. That better be my last number, and I better not touch out once it gets to 0. So once n is 0, stop the process, stop this, it's a loop, right? Stop the loop and output the value of the out variable. Okay, does that process make sense? Just, well, you got a number from the user, keep multiplying it into an answer variable and decrementing it to get to the next numbers that I need to multiply into that same answer variable. Okay, we good with that? So that's going to be the process, and let's code it up. Off to Scratch we go. So scratch.mit.edu. Here we are. Start creating. All right. So what do I want to do? Well, I need to get a number from the user. Let's have this start when the green flag gets clicked, probably is a good idea. And I'm going to store two variables, right? I'm going to have an n variable and an out variable. So I'm going to rename this default one to n, and then I'll make a new one called out. So I have two variables. I can check them both to show them here. That's fine. Interesting. And then, let's see, I would like to have the Scratchcat ask for whatever we want n to be, right? And then n will be placed into this answer variable. So like, I don't know, enter n, I guess, colon, and wait. And I'm going to get a number from the user, like I'll type something, and then it's going into the answer variable, right? That holds what I just typed. And what I'd like to do is put that in my n variable, because the n variable I'm allowed to touch. Like regular variables in Scratch I'm allowed to change. The answer variable is special, and I can't change it unless I ask a new thing. So let's take whatever answer is, whatever we got from the user, and shove it into the n variable. Set n to hold whatever answer holds. Okay, so that's the process. And so if I run this, 42, now n holds 42. And if I rerun it, 33, now n holds 33. It's got everything that I want. Okay, so that's a good start. And then there's a loop involved, right? We want to do a bunch of stuff. we want to keep multiplying n into out and changing n by -1, so decrement it each time, until n gets to 0. All right, so there's going to be a repeat until loop going on. Repeat this process of multiplying n into out, decrementing n, until n is 0. Because when n is 0, I do not want to continue because that'll make the whole answer 0. All right, so this is our loop. Repeat the thing inside until n becomes 0, because that's when I want to stop. Right? Repeat until n is equal to 0. So I need an n, I need an equality check. Repeat until n is equal to 0. And what do I repeat? It's always take my current value of n, shove it into out, multiply out by n. And do that a bunch of times, decrementing n each time. So the first time it's 5, multiply that into out, and then make it 4. Okay? So that's going to be a bunch of setting stuff. So set n to 0. No, it's set out to whatever. Out is times n. Let's see here. And I think I'll need to fix something as well. Set out to be out times n. And then I would like to decrement n to make it smaller. If it was 5 first, I want to multiply it 4 next into out. So I want to change n by -1. Alternatively, I could say set n to n minus 1, whatever you feel like doing. And so this is a good start to the program, though there is something wrong with it. Does anybody see a reason why this might not work right now? The loop is good, though. It's like, until this happens, multiply out into n, change n by -1. Is there anything I forgot? Let me try running it. Enter n 5. And it really will do the work, and eventually becomes 0. Actually, here, let me put a little wait loop, or a little wait 1 second thing here so you can watch the variables change. Enter n 5, and we'll watch it change. 4, 3, 2, 1. I keep multiplying it into out, but what's wrong with out right now? You see it? Yeah.
Out is already set to 0, so you're just multiplying everything by 0.
Good. By default, n is set to, or out is set to 0 when you make a new variable in Scratch, and then also when you rerun the program, it's whatever it used to be as well. So if I want out to have a special value like 1 that it needs to be, I need to initialize it at the very top of the program. Good. So that is what I have not yet done. So set n to answer, set out to 1, and then it will accept the things that I want to shove into it. It'll actually keep it, make it non-zero. Okay, so now I'll type 5, and then watch it multiply 4 into 3 into out, 2 into out, 1 into out. Now n is 0, and that stops the loop because we're repeating this inner thing in this body, right, until n is 0. Now it is 0, we're done. Okay? And so out holds 120. This was just little check marks to help us watch it work, technically. Maybe we should be having the Scratch cats like yell out the answer. Say out for 2 seconds or something. And maybe that's the full answer. Who knows? So that is looking pretty good to me. 5 factorial is multiplying into out. You can get rid of the wait 1 seconds. I'm just showing it so that you can watch the computation take place, and then the answer is 120. 3 factorial, what's that? That's 6. 3 times 2 times 1. Cool, it seems to be working. Are there any questions about the code so far? Because that solves the main problem. There is, however, another issue. If I ask for the factorial of some number that the factorial doesn't exist for, so like I'm typing -5 here, well, repeat until n is 0. Keep on multiplying n into out, subtracting 1 from n. Is it ever going to get to be 0? Look at how it's getting giant, and actually it's oscillating because I'm multiplying negatives, and eventually, like, every two rounds that makes it positive. And so now I have giant numbers, and it's just never going to stop. It'll just keep going down into negative infinity, and there's no 0 over there. Okay? So that's an error. We should not allow this in our program, assuming we want it to always work. So that's our subproblem here. The factorial of negative numbers is undefined, and our loop is not happy about it also. So let's fix that. Let's check if the user typed a negative factorial, then we should not allow our loop to work. Okay? And what we wanted to do is keep multiplying n into out as long as n is greater than 0. As long as n is greater than 0. So once it got to be 0, we wanted to stop. If it's ever smaller than that, one, the factorial doesn't exist, and then also, like, we should stop our program. So we can put, after we get n, for example, or we could even use answer, but before we do this loop, before we do weird things and maybe loop forever, we should check, hey, is it true that I got a bad number for n? If n is less than 0, if n is less than 0, so it's negative, then yell at the user. Be like, factorial of negative numbers does not exist. Yeah. So there we go. I'll zoom out a little bit so you can see all that. Factorial of negative numbers does not exist. And then you also want the program to not continue, because it would right now yell at the user and then continue, right? And it's gonna go on forever because now it's in the loop. We want to stop the program. Don't allow it to get to this loop. So that is in control. Stop all. Do not let the program continue. So now I can do -5. Factorial of negative numbers does not exist. Stop. Program's over. And then factorial of +5. It does the right thing. It gets to the loop. It skips this error message because n was greater than or equal to 0. And it's all happy. Okay. So here is a zoomed out version of the entire program. Are there any questions about this one now? Because that's the right answer. That's the right way to do it, I would say. And you should check it for every other corner case as well. Like the factorial of 1 is just 1, and it is going to work. It's going to print that out just fine. The factorial of 0, surprisingly, in mathematics is defined to be 1, and our loop is going to work. Like repeat until n is 0, and out just starts out at 1, so it's going to skip the loop and just print 1. It's perfect. But when it's negative, that doesn't work, and we checked for that now. Okay? Am I good with that example? It's an interesting one. Definitely study it. So there we go. Save that so I can give it to you later. Why is my attendance still loading? That's weird. Try again. Little attendance app. I'll stop it eventually anyway. Maybe I lost the internet. That would make sense. I'll figure it out. But that's our first program for the day. Let's keep on trucking. If we're good, please yell at me if you have any questions about things. So that's the first example. Next example is let's sum up all the numbers from a starting point to an ending point. Let's get two things from the user, like n1 and n2, whatever those are. Maybe n1 is 2 and n2 is 7, and let's sum all the numbers from n1 to n2. So like if the user gives us these two things, 2 and 7, let me write it over here. The user gives me 2 and 7, then I need to add up 2 plus 3 plus 4 plus 5 plus 6 plus 7. That's the answer I want to compute. Okay, so, well, it's kind of easy to understand what the inputs are. We need two numbers, right? So get them from the user. We can call them n1 and n2. They're both numbers. And what's the output that we want? Well, we need to compute this big long sum, and the answer is just a single number. So the output is one number. Okay, so that's the inputs, that's the output. And the goal is to sum from those things, from the starting point to the ending point. And again, you can break that down to the main problem, like computing the sum, starting, like you have these two variables, add them all up like this. But there's also a sub-problem where there might be an issue, right? What if the user says, add up all the numbers from 7 to 2? And the numbers are supposed to be increasing. So maybe there are no numbers between 7 and 2 increasing, right? So maybe the answer should be 0 in that case, or maybe we should yell at the user. That's up to us, right? But that's a problem that we'll have to solve eventually. So it's good to think about it. But the main problem is actually computing the sum from the first number to the second. So let's talk about how to do that. Well, first of all, we have our two input variables. We have n1, maybe that was 2, could be anything. We have n2, maybe that was 7. And then we have to make another variable this time. We can call it out again, I guess. But it's got to hold the sum, right? We're going to put the sum of all those numbers from 2 to 7 into the out variable. And because we're summing a bunch of numbers, we don't want to offset it in any way. We want to start our out variable at 0, so it's not affecting the answer, right? 0 is the right value to start with addition. and 1 is the right value to start with multiplication. This process for both of these, by the way, is called accumulation. We're accumulating a bunch of numbers together. If we're multiplying a bunch of numbers, we have to start at 1, accumulate into 1, and then if we're adding a bunch of numbers, we want to start at 0 so that we're not affecting the answer. Like, otherwise, it would be like 1 more if we started at 1 than it should have been. Okay, so this is an accumulation process all over again. And so yeah, the goal is to add a bunch of numbers into this out variable. And so here's a good strategy. Well, what's the first number I need to put into the out variable? That's the 2. So let's use n1, and let's add n1 into out. Now we'll put a 2 in there. And then what's the next number I need to add into out? 3. Well, that's the one after whatever's in n1. So let's do this. Let's put n1 into out and then increment n1. And now it's 3. That'll be the next number that I want. And then I can use n2. I just won't change n2, but I can look at it, compare it to n1, and see if I'm done yet. Does that make sense? That's going to be the strategy. So add n1 into out a bunch of times. So now we have 2, add the 3 in as well, make it 5. 2 plus 3 is 5. The next number I need to add is the 4, right? That's the next number in the range. Add the 4 into out. Now out holds 9. Make it 5. Add the 5 into out. Now it holds 14. Make it 6. Add the 6 into out. Now it holds 20. And then we have 7. N1 is 7. Add the 7 into out. Now the answer is 27. And that was the last number I wanted to add, right? 7. So if we follow this process, like this is where we want to stop, but maybe we should let it get to 8, and that's our stopping point. Like we don't want to put 8 into out. That's too big. And so what we should be doing is constantly comparing ourselves to N2. If we ever get bigger, then we're done. See how that process is working? So we want to repeat all this stuff. Oops, sorry. I want to repeat all this stuff until N1 gets bigger, because that's a bigger number than the last number I wanted to consider. All right? So repeat all this stuff. Repeat until N1 is greater than N2. That's the process. So add N1 into out while it's less than or equal to N2, because that's like the last one that I care about. So once it gets bigger, then I'm done. So repeat until it's bigger. And then also I want to increment N1 to make it like I started putting 2, adding 2 into the sum. The next number I want to put in is 3, not 2 again, right? So I need to increment, right? That process makes sense to us, very similar to the other one. But now we have 2 variables, and now we're just shoving N1 into out, incrementing N1, as long as it's less than or equal to N2. Okay? That is the idea. So, yeah, with that, let us write that program. File, new. Sure. What do I need? Let's do a green flag. Let's get 2 numbers from the user. So I'm going to need 2 variables to hold them. N1, I need an N2, and I'll need an out variable. I'll just check them all, because why not? There you go. And then I need to get those numbers. Like, what's the first number? What's the second number, user? So I'm going to need to ask the user twice, once for each number. Ask, enter N1. And wait. And then after that one's done, answer will hold the value that we want to put into N1. So let's do that. Set N1 to whatever's an answer. And then I want to do this all over again for N2, right? So let's duplicate. Now enter N2, please, user. And we'll set N2 to whatever answer is now. So that's how I get those 2 numbers at the start. And then out needs to start at 0. We're good at initializing, right? So out better start at 0, always. Clear it out from any previous run of the program. What else? Yeah, I think that's where we want to start. And then repeatedly, we want to repeat a process. It's a loop. Repeatedly do something, do all this stuff, add N1 into out, increment N1, until N1 is greater than N2. So until N1 is greater than N2. That's when we're done. That would be too big at that point. I don't want to add that number into the sum. So until n1 is greater than n2, I want to do the following. Take n1, whatever it is, add it into out. So set out to be out plus n1, or alternatively I could say change out by n1. Set out to be whatever it is plus n1. Where's the plus? And so that'll increment it by whatever's in n1, so like the 2 the first time. And then the next value I want to put into out is the 3, so let's increment n1. So that's the next number I want. So, change n1 by 1. And so that's the process. Just keep on incrementing and doing cool stuff. And again, I'll add a wait block so that we can watch the values all change. Technically, you don't need it though. So now let's get these numbers. Well, this is a weird order. Here, how about this? Enter n1, 2. So now n1 holds 2. Now let's enter n2, 7. Now n2 holds 7. And it's going to keep adding n1 into out until it gets bigger than n1, because then I'm done. And I want to add the a10. Just stop now. The answer is 27. Okay? Any questions about how that's working? Then we can have the scratch cat yell out the answer if we want again. Say out for 2 seconds. And so now, enter n1, 2, enter n2, 7. And now, eventually, if you get rid of the wait block, it'll be immediate. The answer is 27. Any questions about this version of the program? I'm good with that? See why it's working? And it will add any number, a bunch of any numbers. So like add all the numbers from 1 to 10. Like it'll do that. It'll keep on incrementing n1, starting at 1, going all the way to 11, and 11 is where it stops. Keep on putting it into out. And yeah, the sum of the numbers from 1 to 10 is in fact 55. So that's great. And so that's solving the original problem, the main problem. But we noticed that there could be issues here still. Here's an issue. What do we need to do? What happens if n1 is bigger than n2? Like if the user says, sum up all the numbers from 7 to 2 instead of 2 to 7. Scratchcat is going to do nothing because n1 is already greater than n2. There kind of are no numbers in that order between 7 and 2. So maybe the answer really is 0. But you could also say that maybe the user made a mistake and we should tell them about that. So if we get numbers that are bigger, n1 is bigger than n2, like their equal is fine. It's like the sum of all the numbers from 5 to 5, that's just 5. That's fine, and it's going to work. But if n1 is bigger than n2 at the very beginning, then we kind of have an issue. Oh, shoot. That's a bigger issue. I want an if right there. If n1 is bigger than n2 before we start, then that was probably a mistake. Oops. We can say, I don't know. How do we yell at these? Or like, I think you got the order wrong. Or there are no numbers in that range. Something like that. And then also we don't want to continue, so let's stop the program. And so no matter what, 7, 2, that's like there are no numbers in that range, and it stops the program. Good. Otherwise, if we give a normal range, like between 1 to 5, it's going to do its thing, and it will be happy. Yay. So yeah, that is, I think, a good version of the program and where I want to stop. Any questions about that? Come on, Zoom. Needs to go away. There we go. All right. Fun math examples today. Let's see here. Oh yeah. So here's a fun example. Let me show you how to make your own blocks. This is interesting. So let's see here. Yeah, that's where I want to go. So I think that's the one main piece of Scratch that I haven't shown you yet, and it's very powerful. So you know that we can use a bunch of blocks. Like we've used blocks, we've dragged them out here, and we can use them as much as we want. But wouldn't it be nice if we could make our own block that did something, some large computational thing for us? Like we can make a block that sums all the numbers from 1 to n. Wouldn't that be cool? We can make a block like this, sum, and then it'll print out the answer. Sum from 1 to, and then we can even give a little spot for the user, whoever is using our block, maybe us, to put the value that we want to sum from 1 to. Isn't that cool? So that is the idea. So we can encapsulate a lot of things because it takes a lot of normal blocks to make this one. But once we've done it once, we could make our own block and use this all over the place, multiple times. Isn't that cool? So let's learn how to make our own blocks. We'll make a block that legitimately sums all the numbers from 1 to something. And so that's down here in my blocks, the last place that we haven't been in Scratch. We can click make a block, and we can say sum from 1 to, and then let's add a number as an input. And there it is. We can call it, I don't know, n, whatever we want. And we can click OK, and that is a block. Now we have this block. We can use it in our programs. We just have to say what happens when we run it. And so there's this definition as well. It's like a definition event. So every time this block runs, we can run it a bunch of times if we want. Every time it runs, though, it's going to jump up here to the definition and use the definition, right? So that'll be cool. So when the green flag gets clicked, let's sum all the numbers from like 1 to 5, and then we'll sum all the numbers from 1 to 10. We'll use our block a bunch of times, and all we have to do is say what it means for this block to be executed. What do we want to have happen? And so the first time it runs, like it's going to jump up to here, and this little n variable, it's a variable local to the block definition, it's going to be set to 5. And then we'll run it with that value. And then the next time we run the block, it'll jump up to here again, but this time n will be set to 10. And that's how we do different things for different inputs. And so this is a definition. We have to say to Scratch, what do we mean? What do we want to have happen when this block runs? It's our own block. We have to spell out what needs to happen. So let's do that. Let's sum all the numbers from 1 to 5, and I don't know. I'll make a variable called sum. I'll make a variable called x. I don't know. And so I'll just do this very quickly. But here's how you sum all the numbers from 1 to some value called n. How do we do it? Well, let's set our sum block to 0, or set our sum variable to 0, set our x variable to whatever was given to us in n, because now we can change x. We can't change this n. And then I'll loop in the normal way. So I'll repeatedly, let's see here. How many times do I want to do it? I'll repeat until n is equal to 0, maybe? That'll work. Or by that I mean x, because I'm putting x into n. This is not as important. I trust that you know how to sum from 1 to n, but this is the custom block part that's important to me that you understand. So let me just implement really quickly how to sum all the numbers from 1 to n. So I'm starting x at n. I'm going to add x into sum. Change sum by x, and then I'll decrement x. Change x by -1. In theory, that'll work most of the time. And then the sum variable will hold the answer and let me say that answer. So that is a custom block definition, and now let's watch it work. So what's the sum of 1 to 5? That's 15. What's the sum of 1 to 10? That's 55, and it's working. Isn't that cool? So every time I use this block that I just made for myself, what it does is it jumps up here. Like, let me separate these. It jumps up here. There it goes 15. There it goes 55. It jumps up here to the definition block, the definition of the sum from 1 to block, and it does all this. And the value that I put in the circle here, could be 5, could be 10, could be anything, gets set into this special definition variable called n. Okay? And I can use that in my computation. Like that's set to 5 the first time I use the block. That's set to 10 the next time I use the block. That's how I can get it to do different things. I'll give it different inputs, and it gets to see those inputs. Are there any questions about that? It's a very powerful concept. So now this idea of summing, I can do a million times if I want. I never have to rewrite how to do it. I can just give different inputs to the block. Isn't that lovely? So that's how you can create your own blocks, custom blocks. And so that's a good start. And so, yeah, the goal of all of these things, the reason we want to do this is that it helps us break down our problems into smaller pieces. Break down problems into smaller pieces. And in Scratch, that means smaller blocks. That's the idea. So let's make our own block for Pong. Remember, there was an if on edge bounce block, and we used that. Wouldn't it be nice if we had like if touching paddle bounce block? Let's do that. Let's do our bouncing. So I guess right now we're bouncing in this direction. But let's make a block that just says if we're touching the paddle, let's bounce off, because that would be a lot cleaner to look at than a big if block like we had before. So let's use a custom block in our Pong program. Let me save this one for us first. And then let me load from my computer. No clue where I'm going to find this. It's definitely on the desktop. Code from class, CSCI 1. I assume it was last lecture. I think it was this one. So this is our old Pong program, most likely. Let's see. Yay, so this is our Pong program. Here it is, following the mouse and all that. Whee! So it works. Stop. And what we did, if you remember, we had this was our if we're touching the paddle bounce. And it would be much easier to look at this if this wasn't a big long if block, right? If it was just one like this, if on edge bounce, if it was something that looked like that. So let's make our own block called if touching paddle bounce. Won't that be nice? Because then, let's move this. We have to give a definition. Because then, and this will be essentially the definition, watch how easy this implementation looks now. It's like move 10 forever, the ball, move 10 steps in your current direction. If you're on the edge, bounce off. If you're touching the paddle, bounce off. You see how clean that is? That looks so much nicer. And that's easier for us to reason about as humans. And all we have to do is say what happens when we run this block. So we go up to the definition and we put what we had before. This is what it means to do the if touching paddle bounce computation. It's like, all right, have an if block. We need that somewhere. If we're touching the paddle, then change our direction and let's bounce off. And this is going to work. Every time you run this block, it'll jump up to the definition and run all this code, but it's kind of unnecessary for me to see that down here. I've shoved that problem off to a different part of the screen that's not necessary. And it all still works just fine. And I think that's a much easier program over here to read. I think you might agree. So that is the new Pong game. Are there any questions about what I just did? I made a new block called if touching paddle bounce, and this is what I want to have happen when that block runs. I have to say that because it's a brand new block. Scratch doesn't know what I mean until I tell it. And then also I promised you that we'll get normal bouncing. Like right now, if the ball comes in, it bounces off 180. It does a 180. But really, it should be bouncing off like that. That's the better way. Like it should come in, bounce off like that. So let's figure out what that means. Let's figure out how to do that in Scratch. So here's the ball. I don't know. Here's the paddle. Here's the ball. Let's figure this out. If the direction of the ball is coming in like this, I don't know, coming down negative 130 degrees or so, it should bounce off this way, right? It should bounce off somewhere over there. And if you look at the directions, like it came in negative 130-ish, and we want to bounce off over here, ooh, that's positive 130. That's nice. If it's coming in from the up, like it's coming in this way, we want to bounce off this way. So it was coming in like negative 30. We want to bounce off. Ooh, that's positive 30. Ooh, that's a good pattern. I think that's going to work. And then here we have, if it's coming in straight on, negative 90, we want it to bounce off. Ooh, straight on again in the opposite direction. That's positive 90. Oh, shoot. That's always going to work. Thank you, scratch makers. It looks like if we just negate our direction, we'll always have it bounce off in the way that it should. Instead of adding 180, we'll just negate our direction, make negative 140 positive 140, and that will be the right way. Make negative 50 positive 50, and that will be the correct new direction for our ball. Isn't that cool? And oops, I think the comment didn't go with this. There we go. So that, instead of pointing off and going 180, let's bounce in this way. Point in direction, well, take our current direction and negate it. Negative direction. So direction times negative 1. That will always send, I don't know, negative 50 to positive 50, negative 140 to positive 140, negative 90 to positive 90. It'll always work out. That's what it means to bounce off the paddle in the correct direction. That's how Pong really works. Okay? So, in theory, oh yeah, look at it bounce off in the correct way. Now it should go up. Yeah, that's much better. And so, yeah, it just took a little thought, but that is a much better game of Pong now. Any questions about how this code is working? Definitely fun to watch your creations come to life and do exactly what you wanted them to do. And let me lose now. There we go. Any questions about that? So we made a new block, which is nice, makes it easier to reason about this program now. And then we also figured out the correct way to bounce off. This is what we want to have happen whenever we run our new block. All right. So I'm saving that so you can play the real scratch now. And then I think that's all that I want to talk about on this slide. Let's keep on trucking then. So here's an idea. Let's implement a state machine. I told you about state machines before. Let me show you how useful they are. So here's our problem. We're getting a number from the user, and we want to determine whether or not that number is divisible by 5. But we're getting the number from the user a single digit at a time. So the user, maybe they want to type, they want to ask us, hey, is the number 510 divisible by 5? But they're going to enter it one digit at a time. They're going to enter the 5, then the 1, then the 0. And maybe they want to enter even more. Like maybe they're going to, like this is the number they're going at. And so they're going to enter 5 different digits, one at a time. And the goal is, no matter what, we want to tell the user if the number that they've entered so far is divisible by 5, if it's a multiple of 5. All right? Just quickly, how do you guys know? How do we know that this number is divisible by 5 and like this number is not? How do you know that? And like this number is divisible by 5, but this number is not. What's the pattern? Yeah.
Isn't there a modulus function in Scratch where you can tell how much is left over if you divide it and then just see if that result is 0?
Oh yeah, that's absolutely true, but let's pretend we're just humans and I give you this number. You should be able to say in like a second why it's divisible by 5. You can just read it off, right?
5 or 0 on the end.
Very good. It's the last digit. The last digit is the only thing that's telling us if it's divisible by 5. So like we don't even care about any of the previous digits. And that is going to lead to a state machine solution. If the user types whatever number they want to check if it's divisible by 5, they type those numbers one digit at a time, then here's what we can do with each digit that we get. Like the first time, we're just going to be oscillating between two states. The number that we've entered so far is not divisible by 5. And the number that we've entered so far is divisible by 5. Isn't that cool? So, of course, you haven't got the number at the beginning, so the starting state is going to be not divisible by 5. But if the user types the number 5, like we've just seen the number 5 so far, that is, well, the number 5 is divisible by 5, so we should be moving to this state. And if the user types the number 0 next, now the number is 50, and the last digit is a 0. it's always the last digit. If it's a 0 or a 5, if we ever see a 0 or a 5, the number is divisible by 5. And then if we keep seeing zeros and 5s, like the number 55 is still divisible by 5, 555, 5,550, those are all divisible by 5. We keep seeing zeros or 5, we stay in that state. Otherwise, if we see digits that are not 0 or 5 as the last digit that we saw, we know immediately that that number that the user's been entering in so far is not currently divisible by 5. It only is if it's ending in a 0 or a 5. And of course, if we keep seeing non-zeros and 5s, it's still not divisible by 5. And so that is going to be how this works. And so we're going to program this. Let's program the state machine, and here's how we'll run it. Like, we'll start it off in the not divisible by 5 state, and then we see the digit 5. And so that now the number that we've seen so far is just the number 5. And so, yeah, 5 is divisible by 5. Cool. Then the user types the digit 1, which is not a 0 or a 5. So we're going to move to the not divisible by 5 state because the number that we've seen so far is 51. 51 is not divisible by 5. Then the user types a 0, and we go right back to the divisible by 5 state, and we'll say, yes, 510. That's the number we've seen so far. Maybe the user wants us to stop there. Yes, it's divisible by 5. If the user types more digits, like, no, I'm not done yet. If they type in 8, that's not a 0 or a 5. We move to this state, and so we should say, no, that number, 5,108, is not divisible by 5. And then if their last digit is a 0, we go one last time from the not divisible by 5 state, following this transition to the divisible by 5 state. And what do you know? That one is divisible by 5. So we're going to code this state machine and how it transitions. We're going to write this in Scratch. Okay? One digit at a time, get a potentially very long number from the user. Just one digit at a time. We'll keep telling them, we'll keep updating our state. Is it divisible by 5? Is it not divisible by 5? Okay? So the idea is we can't draw this picture in Scratch. We have to implement the state machine. And so what is the essence of the state machine? It's just, well, it's what state are you in, and then what happens in each state. So we're essentially going to need a variable, and we can call that state or something. We need to keep track of, in our Scratch program, what state we're in. We're either in the not divisible by 5 state or in the divisible by 5 state. How can we differentiate the two? Well, let's encode the fact that like we're in this state with maybe the number 0, and that's like the starting state. So that's what state will be. 0 means it's not divisible by 5, and then if we ever move to this state, that should be 1. We'll encode that as 1. So if these are types 5, then we're going to change our state to 1, and then worry about the transitions in and out of my current state. Does that make sense? There's a question in the chat. I'm sure that is, let me answer this really quickly. Whee. There we go. So, yeah, that is the idea. That's my state machine. And so this is just the variable. It's going to keep on oscillating. It's going to keep on changing from one to the other. Let us implement that. And I'm pretty sure I saved this. Yeah, there it is. So here's what we'll do. We'll get a number from the user, a single digit at a time. So when the green flag gets clicked, I'm going to do a few things. I want to start my state machine in the not divisible by 5 state. So I'll hold that as 0. I'll call that 0. And let's see here. Dun, dun, dun. When the green flag gets clicked, I will have a state variable called state, and that's what I'm going to use to encode what state I'm currently in. And so at the very beginning, I'm in the not divisible by 5 state because I haven't read any digits yet. And then repeatedly, forever essentially, until the user wants to give up, forever, until the end of time, let us change state by whatever we need to change it by. Maybe it's divisible by 5 and we should change it, okay? So here is this state. If I'm in state 0, I need to change it if I see a not 0 or 5 or if I see a 0 or 5. I need to do two different things. And same for this state. If I'm here, I need to change it if I see a 0 or 5, stay in that state, otherwise move to the other one. So that's going to be essentially an if statement. So forever, run my state machine. So I need to get a new digit from the user, enter the next digit for 2 seconds, and then answer will hold. Oh, sorry. Wrong block. Enter the next digit and wait. And now answer holds the next digit. Maybe the user typed the 5, or they typed a 1 or a 0 or an 8 or a 0, whatever they had. And then the idea is to use this answer to change our state machine. Does that make sense? And so our state machine works in two different ways. Either we're in the 0 state or the 1 state, the not divisible by 5 state or the divisible by 5 state. And so depending on that, we move around differently. So there should be an if-else block going on here. If the, this is about our state right now. We have not checked the answer yet. We don't care what digit until we know what state we're currently in. So if the state is 0, if state is equal to 0, then I know I was over here. If state is set to 0, then I know I'm here, and I want to run the state machine from the perspective of being here, because maybe we have different transitions for different things. And then otherwise, I know I was in the 1 state. I know I was in the divisible by 5 state, and I should run based on my answer to somewhere else. Okay, so now I know where I am, so this figures out, based on what state I'm in, what do I need to do? Now, if I know the state's 0, so in here in this inner body, what do I need to have happen? If I'm here, I need to transition if I saw a 0 or a 5, or if I saw a not 0 or a 5. I need to stay in the state or transition. So that's going to be another if else inside of this one. So if the state is equal to 0, then depending on the answer, whatever digit I just got, I need to move my state along. So if the answer was the digit 0 or the digit 5, I need to transition to the divisible by 5 state, because the number so far now is divisible by 5. That's going to be the idea. So if the answer is equal to a 0 or it's equal to a 5, if either one of those are true, so I'll use an or block. If the answer is 0 or it's a 5, then I know I'm in state 0, and then I know that I just got a 0 or a 5. I need to change my state to be in state 1 now. And what does it mean to change the state? In the program, we're using the state variable to tell us where we are. So change state to 1, set state to 1. So there's a lot going on there. So set state to 1. Otherwise, else, that means it wasn't. We were here, right? We're in this state, and we saw a non-0 or 5. And so we should stay. We should stay in state 0. So technically, I don't even need an else, but because my state is already 0. But we can set it to 0 again if we want. And so that's what I want to have happen. This whole thing right here, this is what I want to have happen. This is running the state machine in the not divisible by 5 state. Okay? Any questions about that? Because I still need to say what to do if we were actually in the divisible by 5 state. How do I move around? That's this else case. If the state wasn't 0, then it must have been 1, and now I need to do some more stuff. And it just so happens that it's the same stuff. So you can simplify this pretty greatly. But if I'm in this state and I see a 0 or a 5, I still want to set my state to 1. I want to stay in this state now. So if the answer is 0 or 5 when I am in the divisible by 5 state, then I want to stay in it, set state to 1. Otherwise, I saw a not 0 or 5, and I want to move back to this not divisible by 5 state, and that's state 0. Okay? So there's a lot going on there, and I think I don't have enough room to show it all to you, but let's just output the value of state. Let's watch it change each time, because this is a forever loop. Forever. So first of all, set the state to 0, and then forever do all this. And let's watch it work. So state is 0 right now. I'm in the not divisible by 5 state. But all right, the first digit is 5. And for some reason, it's not letting me type. That's not good. I think there's an issue with my Scratch right now, and that is no fun. No, let's stay on the page, please. I don't know what's wrong. Can I type here? Wow. Okay, there's something horribly wrong with my Firefox right now. I'm very sorry about this. Can I type here? No. Am I holding Alt somehow? Ooh, boy. Something really weird's going on. Sorry about that. Well, I guess what I can do is save this right now. Having some technical difficulties. Let's save this, and maybe if I restart Firefox, it'll be happy. Is this? Yeah, that's so odd. It's as if I'm holding in Alt when I'm not. All right. Leave. Let's come back. I have no clue what the problem was there. Sorry about that. But what was supposed to happen was we're going to watch the state value change. Gosh, is Firefox not even opening for me? This is fun. It's trying. Slowly but surely, maybe. My poor computer. Got too many things open, maybe. Well, first of all, can I type? No, I still can't type. Yeah, I think there's just something wrong with my computer, guys. I'm sorry about that. Well, I promise it works. Let's see, what could I do? It thinks that I'm holding in a key, I think, somehow. Is that... could be the fault of this program? Yeah, I don't really know how to fix that. Let's see here. So, I might just have to stop. I'm sorry about this. Let's see. Let me try plugging in a keyboard. That is not my current keyboard. Let's try that. If that doesn't work, I give up. Because when I type on this keyboard, it thinks that there's something wrong. All right, moment of truth. Can I type something on this keyboard and have it work? No, I cannot. Okay. All right, I officially give up. But here's the program. I guess we can't really do much else today. Sorry about that. Load from your computer. Let's go back to the actual program at least. I promise this would work, but I don't know. Let's try and watch it happen. Yeah, it really thinks I'm holding something in right now. That's so odd. Ooh, something happened. I can type again. Okay, cool. Let's keep going with this. Enter the next digit, 5. Yeah, there we go. And so state changed to 1. You see that? The state changed to 1 because we were in 0. The answer was a 0 or a 5. Now the state's 1. If I type 1, and now the number's 51 in total, then the state moves back to 0. You see that? because we were in the state 1, that was this else case, and I did type a non-0 5, so we set the state back to 0. Then we do 5 again. 5, now I type 515. That 515 is divisible by 5, so we go back to 1. Then I can type an 8, type a 0. It's always based on the last digit, and this is me running the state machine in code. Yay. I'm excited that it actually worked. No clue what was going wrong. But yeah, are there any questions about this code? Because that's kind of the idea. That's where we were going. And, oh gosh, no thank you. That is what I was hoping to do at least. At least it's slightly happy. So with that, I did already save this. I'll keep it on the screen, maybe. Make it very small. We have a little while. I want to give you guys a couple minutes to try something like this. Like, here's the ugly code. You can simplify this pretty easily, though. This is my divisibility by 5 state machine. Actually, maybe I should just show you this. I should give you this again. I have a question for you to try. You don't have to code it if you don't want to, but at least discuss how to create a divisible by 2 state machine. So if the user types the number a digit at a time, like they type 1,234, like they type the 1, the number 1 is not divisible by 2. It's not even. So you should say no, but once they type a 2, that means it's 12, and now that is an even number, that is divisible by 2. And then once they type 3, now they think it's 123. That's odd, it's not divisible by 2. But once they type 4, now it's 1,234, and suddenly it is even. So how do you use this kind of idea, the same kind of idea? How would you create a divisible by 2 state machine? See if you can figure that out. Take a few minutes to discuss with your neighbors. Try to draw it if you can. I'm asking if you have any questions about anything while I re-plug in this keyboard. How would you be able to use the same idea and discover that a number is divisible by 2? What that means is even. Evenness versus oddness. How would you change this? All right. Do we have any thoughts? How can you determine whether a number is divisible by 2 rather than 5?
You could divide it by 2 and see if it's a whole number.
Yeah, that works. That also works. But assuming you're getting it a digit at a time again, is there an easier way?
Could check, see if that digit's 2, 4, 6, or 8.
Good.
That could be overcoming, but there could be an easier way, but I'm not sure.
I think that's the best way. That's the one that I have in my mind, at least. Yeah, so you know that if a number ends in 0, 2, 4, 6, or 8, it must be even. And so that's your divisible by 2 state. And then if it's any of the other numbers, if it's an odd number, 1, 3, 5, 7, or 9, you know that if that was the last digit, it's automatically, again, odd. Okay, so if you read a digit at a time, you're going to like oscillate for this particular example. Like, okay, number 1 is odd. Oh, 12 is even. 123 is odd. 1,234 is even. You'll keep hopping between states in the same idea. Yeah, I think that's if you're getting it a digit at a time, which is, I mean, it's a silly example, but it shows off the power of a state machine. Like, this is how I'm moving around, and I could implement it pretty easily with just a single variable and asking for input. Any questions about any of that? I'm glad I got my keyboard to work again. So try programming that if you can. I think that would be a fun example for you. So if we are good, that is the last piece of the lecture that I wanted to talk about. And the very final thing that I want to do, yes, nothing is finished loading because I opened everything up again. The last thing that I want to do is talk to you about your next programming assignment. This one will be due in a while. We'll be due week 9, so plenty of time because we're in week 6 right now. But this one is a very open-ended project. This will be your last Scratch program, and so I want you to go out with a bang. So for those of you who are doing the Scratch programs, here is your assignment. So I just want you to be creative. You can implement anything you want. You're making a Scratch program of your choice. You can implement whatever you want, but you have to do these following things, subject to the requirements. So here are your requirements for your last Scratch program of the class. So your program, it must have at least three key press events. So like move when you press the up arrow or something, left and right, space. Don't recopy the program that you did last time, but do something cool with at least 3 key press events. A mouse click counts as a key press. Also, you must use at least 2 conditional blocks. So like an if then else, or just a single if then. At least 2 of those. Like check if the ball is touching a paddle. That's an example of one that we did, right? You're going to need ifs to do interesting things. So I want you to have at least 2 if then else blocks or if then blocks. Pick a conditional block. And then also, you must use at least 2 loop blocks, like a repeat until, forever, repeat exactly this many times, whatever you want, because that's how interesting animations happen. So like move your sprite in their current direction forever, maybe until they hit a wall. That will involve a loop and then also a conditional block. Okay? So those are your hard requirements. Of course, you can add more to that, but that's what I want to see, and it could be about anything. The one thing you can't do is exactly copy something that we did in class or something that you already implemented, because that's not learning, right? That's taking the easy way out. So I won't give you credit if you do that, but as long as you follow these requirements and make something cool, I will give you full credit. And yeah, so that's the program. Please record a video of it running, explain your code to me. It should probably be a longer video than the ones you've been doing so far because I don't know what you're doing. You're making up something, you're going to have to explain it to me and take a couple minutes doing it, right? So that is the project for those of you who are new to programming. This is your first programming class. Any questions about that one? Reasonable enough? Whatever you want, subject to the requirements. And then if you are doing one of the Racket, if you're one of the students who have this program before and you're doing the Racket assignments, here is your next one. Please read these chapters and do these exercises, and as usual, record a video of it all working out. Okay? Any questions about that? That one should be even more self-explanatory, I hope. So yeah, either make up your own Scratch program or do this thing. We good with both of those options? All right, that is officially then all that I have for us.